Have you ever wondered what lies inside of a black hole? A black hole is such a dense region in spacetime from where even light cannot escape. Remember, traveling at 300,000 kilometers per second, light is the fastest entity in this entire universe. Black holes are the monsters of the cosmos that feed on everything that comes in their way, be it a tiny rock or a massive star. But what lies inside of these mysterious objects? Is it a portal to a parallel universe with different laws of physics? Or is it a wormhole that can make interstellar travel possible? And most importantly, what would you experience if you fell into a black hole? One of the fascinating things about black holes is that before their discovery, they were found hidden in the equations of physics. They are an outcome of Einstein's general theory of relativity. Even Albert Einstein doubted the existence of these bizarre objects in space. But decades later, their discovery delighted the astronomers who were now curious to explore them deeply. Black holes are not merely holes in space. Instead, they have several regions inside them. Let us begin with the outermost part called the photon sphere. Photons are the particles of light. If these photons from a distant galaxy happen to pass by a black hole at a particular distance, they will be captured by the black hole's intense gravity, and forced to move in particular orbits. As you can see in this illustration, the yellow circle represents the photon sphere. If the photons enter this region, they end up getting sucked by a black hole. But if they pass the black hole at a safe distance, they escape the field but are highly deflected by its gravitational field. If the black hole is a rotating one, there's a region around it where it's impossible to stand still. This region of spacetime is termed the ergosphere. In this region, objects and radiation can generally escape. The ergosphere is shown as a light blue region in this illustration. In this zone, all the particles are forced to move in the same direction as the black hole spin. There's a process called the Penrose process in which the particles can escape the ergosphere with more energy than they entered. Then comes the ultimate boundary of the black hole from where not even light can escape, the event horizon. This is an exciting region of the black hole. Suppose you are an observer looking at an astronaut entering a black hole. Because of gravitational time dilation, the astronaut will appear to slow down as he approaches the event horizon. He will start appearing red because of tremendous redshift. Finally, the moment he reaches the event horizon, he will appear to be frozen in time. But the astronaut wouldn't notice any difference at the event horizon. Even after he passes the boundary, to an outside observer he will appear frozen in time. The event horizon is the point of no return, as you cannot escape once you pass it. From the outside, it might seem that story has ended. But that's not the case. The most mysterious region of a black hole lies within its event horizon, the singularity. As per the most accepted notion, a gravitational singularity is a point that lies at the very center of a black hole, and contains enormous amounts of mass in an infinitely small space. Here the spacetime curves infinitely, and the laws of known physics are no longer valid. As per Nobel laureate Kip Thorne, singularity is the point where all laws of physics break down. To avoid this anomaly, a new theory has been gaining momentum. It says that black holes could be eternally collapsing objects that will hit the singularity only after infinite time. This model has been built over the works of many cosmologists and astrophysicists over the past few decades. But if this singularity exists, then where does it take us? Scientists have looked into the possibility that black holes could act as wormholes to other galaxies. Wormholes are the shortcuts in spacetime that can significantly reduce the time required to travel through the universe. Another possibility is a white hole that is the opposite of a black hole. Just like a black hole sucks in all matter and radiation, a white hole is a region of spacetime that cannot be entered from the outside, but matter and radiation can escape from it. Luke quantum gravity says that black holes could lead us to another universe. According to the multiverse theory, there could be infinitely many universes, where copies of you could be watching this video or doing something else. Black holes could be the portals to access another universe.